Hi team, thanks for joining the call. Let's wait for Anusha and Veda as well. Yeah, let's wait for Veda.
Naveda only not joining. Anusha joined.
Okay, will Veda join?
No, maybe she messaged in the group.
Okay, then we can start. Okay,
She is not.
okay, I can't attend today's class. I'm not. Okay, we can start today's class. Okay, let's quickly share my screen. Okay, okay, fine. Let's start today's class. Before I start, right? Yesterday we were discussing till still here. What is Spark? Right? What is Spark? What are the issues with MapReduce? Right? What are the features of Spark that made it like on top of this Hadoop processing, right? MapReduce processing. What made Spark to be on top of this data processing, right? So in today's world, we are using the Spark for the data processing in the real time distributed data processing. So what made it? So all these things we discussed right yesterday. So hope you do not have any doubts on this till what is Spark. At least you have a fair idea on what is Spark. Okay. Any doubts so far?
No, sir.
No. So you're good with Spark. What is Spark at least? If someone asks you what is Spark, what will you say?
It is an open source distributed computing system designed for big data processing and analytics.
Analytics. Yeah. You can add one more very important point, right? We discussed with the difference between Hadoop and MapReduce and this, right? Hadoop is i- Hadoop is very slow and Spark is very fast, 100 times fast. Why? Why Spark is 100 times fast? We discussed a point yesterday. Why Spark is very fast?
It's data take from RAM.
Yeah, Hadoop will load data in do the processing in the ROM only, but this
Yes,
Spark, right, it will do the processing in RAM. Okay,
RAM.
RAM. Okay, so
Okay.
that what made this Spark very fast. Okay, okay, fine, fair enough. At least you have some fair idea on this Spark. Nice. Uh, Okay, I'm planning to create some quizzes as well, but actually I'm very busy with my work, so that's why I'm unable to create. But yeah, I will definitely come up with some quizzes as well. So I will try to upload in this portal. So once I upload, I will let you know. So you can do those quizzes as well. Okay, cool. Okay, let's start today's class. It will be on RDDs. Okay, I came up with some analogy. Analogy means some good example. For now, you can consider them. Okay, okay. So you wanted to make some 100 pizzas. Okay, let's say Anusha alone wanted to make some 100 pizzas. So let's make it some big, 10,000 pizzas. Anusha alone need to make some 10,000 pizzas. Okay, will Anusha able to do that? Right, she will be definitely able to do that, but in her lifetime, entire lifetime, she can make it. But within one day, she won't be able to do that, right? Right. So if Anusha want to make it some 10,000, let's say 1,000 pizzas, she won't be able to make it in single day, right? Then what this that's a big data, right? Big thing to do, right? Now what we will do is we will break this task among, because you five are friends, right? You all are friends, right? Now I will break the task, 1,000 task, into five parts. Okay, so each one need to make 200 pizzas. Okay, each one need to make 200 pizzas. It's also a big task. Okay, at least let's go with 100. Okay, for now let's go with 100 pizzas. Okay, you wanted to make 100 pizzas. It's very difficult for Anusha, so you are a friend. You came to help. Okay, now you need to make, each one need to make 20 pizzas. It's achievable, right? 20 pizzas is achievable. Okay, fine. You will do that. Okay, why I'm telling this entire story, we will let you know once we start discussing these RTTs. Okay, you wanted to do distribution. At least your task, 100 pizzas task need to be distributed into 5 tasks. Distributed, right? Partition, we can say partition, distributed, right? Among yourself. Fine. Now let's go to this analogy. You need to make 100 pizzas. Okay, instead of one person making them all, you give the ingredients to 5 friends. Here the friends, right? The friends who came to help Anusha. Okay, so all of you will be called as the executors because you are the one who are executing the task, right? Your task is to make 100 pizzas. That task is to made into 5 tasks. Okay, 5 separate tasks, and each one is doing that, right? Each one of you is doing that. Now you are called executors. For this entire day, I will call you as executor. Okay, so how do you make the pizza? First thing, you need the recipe, right? Instructions, right? You will take this batter first. You will put it into some water, mix it very well, then put it into the pan, something. So all those things, recipe, steps to prepare the pizza. Okay, steps to prepare a pizza. Now the recipe is the instructions. Fair enough. Recipe is the instructions. The dough, sauce, and toppings are split up. Each friend makes a fraction of the pieces, right? Now each friend will make a part of that pieces, a part of that 100 pieces. Let's say 20 pieces out of that 100 pieces. Now that's what distributed data set looks like. Distributed data set. Okay, so you are doing the task is distributed among yourself. Okay, now you started doing this, so we can think in real time, like your friend is having some 100 pieces, some shop or something, he wanted to make 100, you need to make the delivery. Okay, so that's why she started preparing 100 pieces, and now the task is very huge. Then she called you. Hello. Yeah. Yeah, each friend needs to make a fraction of pizzas. Fair enough, right? Now you are making fraction of pizzas. Each friend, at the same time, each friend do not need to make the entire task. All he need to do is just work on the part of the task. Okay, just part of the task. Fine. Now let's see what is resilient. So now this is a dot for you. So why I'm telling this story? It's a dot. Okay, we will connect the dots later. Okay. Now, while the friend is making their pizzas, okay, they drop their tray. Something happened. Somehow the pizza he made is got lost. Somehow it got fallen into the ground. Okay, you cannot take it and put it in back, right? So somehow it got lost. Okay, instead of throwing a huge fit, they just get a bunch of ingredients, the original data, and reread their instructions to quickly remake their portion. Instead of just throwing entire task, entire pizzas. Till that time, let's say Karthik has made 19 pizzas. Okay, just one pizza. While the last pizza he's making, he done that, somehow it got fallen on the ground. Okay, now he won't throw this entire 19 pizzas outside and he will start from the scratch. No, what it will do, he will do is he will go and bring these ingredients for this single pizza. Okay, that single pizza ingredients he will take and he will start preparing the pizza again. Okay, that's what resilient is. Okay, in case in your data, in your real time, right? Let's say you have some task, right? Each task equal to partition, single partition. We already know the block is equal to mapper task, block is equal to task, task is equal to like mapper task, right? That's what we discussed, right? Now this ingredients, right? Ingredients is the original data. So due to, unfortunately, Karthik lost those ingredients, that original data, that small original data. Okay, now he will again go and fetch that original data. Again, he will start preparing that pizza. Okay, they don't have to start from the scratch. Okay, because the original recipe is still there, right? I do not need to start from the scratch because I know Karthik knows how to, the instructions that he need to follow to make the pizza, right? He don't need to start from the scratch. He don't need to go to the like, let's say there is some supervisor or something. Then he don't need to go there and ask, take permission and all these things, blah blah blah. All he needs to do is like, bring the new ingredients, new original, new data, and then start your processing. That's it, right? Now this is what RDD means. RDD means, for your information, RDD means resilient, resilient, distributed data set. What is resilient? Resilient means fault tolerant. Fault tolerant. Okay, and is capable of rebuilding data on failure. Resilient means fault tolerant and is capable of rebuilding pizza on failure. Somehow you are unable to make that pizza, but you can, this Spark will provide you that capability to just remake that pizza. Okay, and distributed. We already know this, right? Distributed data among the multiple nodes in a cluster. Distributed data among the multiple nodes in a cluster. Distributed data, distributed ingredients. Okay, ingredients among multiple friends in a house, multiple executors in a house, multiple executors in a cluster. Okay, if you remember, if you follow the names right, so you are the executors. Okay, you are distributing your ingredients, that means you are distributing the data among yourself. Okay, then you are working together to make the pizzas. Okay, as a cluster, right? As a cluster you are working, so in between while you are making pizza, so if something happened, something got lost, you are able to rebuild that data. Okay, so data set is collection of these values. That means if you think this 100 task, right, this is you can think this is as a data set. Okay, in a high level view, this 100 task is a single data set for you. Okay, now I hope you guys understand what is RTT. Okay, any doubts so far? Like at least the small example. I don't need to remember the technicality, but just small example. Any doubts?
No, sir.
Right, you are able to understand, right? So your task,
Yes.
you are understand, right, how the tasks are done, right? Now let's see one more analogy. Okay, because I just wanted to introduce some new concept to you, lazy evolution. Now tell me one thing. Are you going to make 100 pizza if you do not have an order for 100 pizzas? Are you going to do that in the real time?
No, no.
No.
Right, same happens in Spark. If there is no order, okay, there is no order, the Spark won't do anything. That means in the technicality side, if there is no action, Spark is lazy evolution. If there is no action, then there won't be no transformation. I mean nothing will happen if no action is called. Okay, let's see how it happens in the real time. Again, baking cakes. This time I'm going with cake example. Baking cakes. Imagine you need to bake thousands of cakes, but only you have one oven. A single person trying to do this alone would take forever, right? Very bad, very bad, right? 1,000 cakes you want to make, but you have only one oven. It's very, very bad. That thing you can, the oven you can think of as an the infrastructure. Okay, that's very bad. Now, the RDD breaks this problem down and distributes the work. The recipe is the RDD. Okay, it's an instruction set of for how to create the end product, how you are going to create the product. Now tell me, to make this cake, right, what is the data, what is executed? Just let me know what is the data we need to make this cake. What is the data? Okay, acha, fine. So what is the data for data to in pizza's example, what is the data we discussed something, right? This, you will what will be distributed among yourself? Hello? Ingredients is the original data. Okay. Similarly, in the cake example as well, ingredients is the original data. Okay. So now you need to create some cake, or you need to create some pizza. Pizza is the end product, cake is the end product. And the instructions, right? Instructions you wanted to make, the steps or the instructions you need to follow to make a cake or to make a pizza is what we call as a RTD. Okay, the instruction set of how to create the end product. Okay, the raw recipe and all the transform versions like the mix batter, bake the cake, and are the immutable. It can't change the original recipe. Okay, what is immutable first thing? Immutable means, maybe some of you don't know the exact meaning. Immutable means not changeable. Mutable means changeable. Okay, now you take the batter, some maida or something, and you pour some water, and you made some mixture. Okay, now can you make maida out of it again? Yes or no?
No, sir.
No, you can't. Right? You can't do that. So that's what immutable means. What happened? Is my screen still visible?
Yes, sir.
Sir,
Yes, sir.
visible.
Yes.
Okay, fine, fine. Okay, okay, right? It's immutable. Okay, immutable. You can't change. Right? You can't change that. You can't change it to the its back version, right? Previous version, which is maida plus water. Now, maida plus water you mixed and you made some good mixture, and you can't made it back to the maida plus water again. Right? You can't do it. It's immutable. Right? That's what it happens in RDTs as well. It's immutable. Any transformations that is done, it's not immutable. Okay, it's immutable. Fine. Now the chefs are the executors. You are the chefs here. You five are the chefs. So you are the executors. Executors means who will perform those instructions, right? You are going to follow those instructions. Who will help, uh, who will help someone to make the end product, right? Each chef only works on small part of the recipe, a partition of the data. Okay, small part of the recipe. That means small part of the data. Okay. Now the kitchen manager, right? Let's say you're doing it in some restaurant. The kitchen manager is a driver program, right? The manager holds the entire plan, BHE, entire plan. They decide which chef does which task in what order. Okay. Here, uh, the preparation of this, right, thousand things, right? So what happens is if you observe any National Geography channel or something, if you want to do something like they wanted to prepare some biscuit packet something, right? What they will do first, they will do some mixture. Okay, then they will do this mixture for entire thousand biscuit packets. Okay, then they will take it. Okay, so step by step, right? They will prepare this step first, then they will go and do the biscuits. Okay, then they will do the packing. Before packing, they need to count number of biscuits they are going to put into that packing. Then at the final stage, they will do the packing. Right? This is step by step process. Right? Now, in Spark, how this happens is, let's say you wanted to extract some data, some insights out of the data you provided. Okay, then first stage, right, you will do some kind of transformations. Okay, once that is done, you will going to do next step. Okay, once that is done, you will going to do third step. Once that is done, you are going to do the final step. Okay, step by step processing, right? The step one is what we call is a stage here. Okay, the instructions we call is, right, instruction means what is the instructions, step by step, right? Okay, let's say you wanted to switch on your laptop, right? What you will do, you will first take your laptop for step one, take your laptop, find out where your laptop is. Then step two, you will put the charging to it. Step three, you will open your screen, right? Step four, you will on the laptop, right? Then step five, you will enter the password, right? That's how you access your laptop. These are the steps involved, right? Now the step one, right? Step one we call it as a stage here, stage. Okay, stage. In that stage, what you are doing in the first stage, I wanted to figure out where is my laptop. I wanted to figure out where is my data. Okay. Step two. Step two. I need to plug in. I need to plug in my charger. Maybe there is no charging. I need to plug in my charger. That is step two. That is stage two. The stage two, the task is I need to plug in my charger. Okay. Now stage three. Stage three. I need to open my screen. Open my screen. Right. That is stage three. What I'm going to do in stage three? I'm going to open my screen. Okay. Now stage four. Stage four, I need to power on. I need to click on my power button. That's a task there, and that will be my stage four. Okay, stage four. Now final stage is I need to enter the password. In the final stage, I need to enter the password. Okay, that is a task involved in the stage four. Okay, so just remind this. Okay, what are the steps? Anything you do, you will follow some steps, right? Each step will represent a stage. Okay, and whatever you're going to do in that step or stage is equal to a task. Okay, so now that is a task. Okay, and for this, right, we discussed, right, yesterday we discussed, right, for a node manager there will be resource manager, right? For a data node there will be a name node, master slave. Similarly, in this Spark as well, in MapReduce as well, you will have a driver as well. Okay, but here it will play very important role. We haven't discussed that there because uh, you are going to get it here. So driver, right? Driver is most important part of your Spark. Okay, your program vehicle. If driver dies, your entire program will get died. You remember application master, right? Application master, same happens with the application master as well. If somehow this application master got killed, lost, failed, anything happened this application master, your entire program will get lost, right? You know that, right? Application master. Similarly, the driver is the main entry point of your Spark. Sorry, main part of your heart. You can call it heart of your Spark job. Okay, if somehow this driver got killed, failed, anything happened to this driver, then entire job will get lost. Will entire job will got failed. Okay, so that is what this kitchen manager is. Okay, kitchen manager is a driver. The manager holds the entire plan. Entire plan means direct acyclic graph, because I'm telling step one and step two, step three process, right? That's what we call as a direct acyclic graph. I'll show you what is direct acyclic graph. So far clear? Any doubts? Because we haven't started this thing yet. What is this? Technical driving set. Okay. What is this escalator? Okay. Let me quickly give you some. Okay. What happened? Okay. Somehow it's not working. Let me go show you tag example. See, this is a tag. Okay. 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 Let me keep it very simple. Simple tag. Okay. Okay. This is a simple tag. Step 1, step 2, step 3, step 4, step 5. Okay. Once the step 1 completed, it will go to step 2 and step 3. Step 2 and 3 can run in parallel. Okay. Once the step 1 is the initial step. Once step 1 started, it will go to step 2 and step 3. Step 2 and 3 can run in parallel. Once step 2 completed, it will go to step 4 and 5. Step 4 and 5 can run in parallel. Okay. Now, once step 4 is finished, you cannot go back to step 2. Okay. It's not acyclic. That means you cannot go back. Okay. Go back. Not only 2, it can never go back to 1. Okay, because 1, 2 and 4 follows, and 1, 2, 5, and 1, 3. 3 can never go back to 1. Similarly, 4 can never go back to 2, not 1, not even 1. 5 also cannot go back to 2, cannot go back to 1. It's a directional. Here you see the direction, right? This arrow mark, direction, and here this arrow mark came here, and you can go this direction. You have two directions. Think this is as an like road. Okay, so it's a one way. Okay, so you will go from here, and either you have any of the two options. Okay, you will go this side or you will go this side. That's it. You can't go back here. Okay, go back here. Graph, it's a graph. Okay, it's directed acyclic. That means you cannot go back to its previous task. Okay, and it's a graph. Okay, that's what DAG means, direct acyclic graph. Okay, hope you understand that. Okay, now this kitchen holds the plan, because I told you, right? Once you made the maida plus water mixture into some thick texture, you cannot go back to previous. You cannot separate that maida and the water again, right? You cannot do that. It's immutable, and you never wanted to, and you won't be able to. Okay, that's what this immutable means, and that's what this tag will also make sure ensure that this is strictly followed here. They decide which chef does which task in what order. Okay? So who needs to do that task, who needs to do that task, in what order they need to do all those things, that will be given by this driver program is the instructor, driver program is the leader here, is the heart of this part job. It will do everything, right? If resilient, if one chef spills their batter, the kitchen manager doesn't panic. If some issue happened, the one chef, what is the chef here? Executive. Okay, if something happens, the kitchen manager Kitchen manager means driver program. Do not panic. Just simply find another chef, another executor, and give them the original recipe and the list of steps to recreate that specific portion of the cake. Okay. Now this is the more efficient than replicating every piece of batter. Right? Instead of starting from scratch and every piece you wanted to start from scratch, right? It will be very better, resilient. Okay. Now lazy evolution. The manager does not start cooking until someone places an order. Right? That's what we discussed just now. You got 100 pizzas order, then only you will start making 100 pieces of order. You are not pagal, right? You cannot make your 100 pieces ready waiting for like you will get an order, right? That's what Spark will do. Spark is a lazy evolution. If someone asks you what is lazy evolution tomorrow, okay, you can say this: no action, no task is performed until an action is called. Okay, until an action is called. Action in the sense until an order. For now, you can think of an order. Okay, until someone places an order, I I won't I won't do anything because Spark won't do anything. That's what lazy evolution is all about. Then let's the manager optimize the entire processes first, like seeking that several steps can be combined into one to save time. Okay, now this manager, right, kitchen manager will make sure that what the steps that involved in making pizza, cake, or whatever may be. So then he will list the list of steps, right? Steps one by one. He will create that DAG for you. Okay, that DAG, and this kitchen manager again decides like who needs to do what he needs to do, right? What was the task he need to perform, right? That's what this lazy evolution and this looks like. Okay, let's go to our technicality here. Okay, so for any doubts, you might have had some idea, right? The moment you got a task, okay, the moment someone gave me a project, I need to see what are the estimation of that project, right? The moment someone asked me to let me say some best example. Yeah, if the moment someone give you any task or any work, you need to see what are the steps involved. That step one, step two, step three, step four steps involved. Now, in our Spark world, we will call these steps as the stages. Okay. Now, what is the step one? You will figure out because you are the driver, you are the heart, you are the manager of this work, right? Now you need to figure out what is the first task you need to do, what is the second task, what is the third task, what is the first task. Okay, then once all these tasks are completed, then only this entire work got finished, right? Now you are doing this distribution, you are separating your task, right? Similarly, this resilient data, this RDD is the default data type in Spark. Okay, you know like what RDT will do, right? Resilient data distributed data set. So in any task, any work you will give to this Spark, right, it will do this. It will distribute the task. It will make sure that it is resilient. That means fault tolerant. Okay, the task you give, the data you give entire data set of data to this Spark. Okay, it will take that, it will distribute that into tasks. Okay, and then it will be resilient means fault tolerance. It will, if one of the data, original data, someone, the executor who is processing the data, somehow it got failed, unable to give the final output that it's supposed to give, what happens is this Spark driver program knows that, right? Okay, somehow this task got failed. Now it will get that original data, that small part of original data again, not the entire data. Again, it will give it to some other executor and ask, hey, this executor is not good. It unable to perform the step. It will give that exact task to some other executor. Then that executor will do the process. Right? Cool. Now, what is fundamental technicality? Okay. Resilient data, distributed data set are a core abstraction in Apache Spark. Core abstraction means, let's say, principle. Every person will have its own ideology, morality, what we call in our side, right? Is similarly Spark will have some core abstraction. Like resilient RDDs are core abstraction in Apache Spark. Okay, here see some key points about RDDs. Fundamental data structure. We discussed just now. Fundamental data type. I just mentioned. I just taking that back. It's fundamental data structure. RDD is a fundamental data structure of Spark. Okay, which allows it to efficiently operate on large scale across a distributed environment. You just saw an example, good example, pizzas, cakes, right? How you are going to make it's a very big, large scale order for you. Then what you will do? You will, let's say I run a company of making a pizzas. Okay, then I got some queues order. Then what I will do, at least I do not have employees, right? I have only two employees, but on that day, on that particular day, I'm not going to the two employees not going to help me to finish the task then. Okay, then what I will do, I will pay huge money, and I will bring some more employees and get them my task done for that day, right? You can get the labor from outside, and you can do that thing, right? Similarly, that's what happens in this Spark as well. That's what we call it as a dynamic memory allocation. Okay, because for that time you need some extra workers, so you just got the worker from the outside, and you just done completed your task. Okay, once the task is completed, you will release those workers. Okay? So you will get to know these things, this dynamic memory allocation. Just remember that dynamic if needed, I will need the memory, then I will get that memory. Okay. Now, once an RDD is created, it cannot be changed. Yes, once it's created, it cannot be changed. You know, right? It cannot be changed. Any transformations applied to an RDD creates a new RDD, leaving the original one untouched. Okay. So, in the data world, in the Spark world, okay, any transformations, let's say, um, where is that calendar? How it's supposed to work. Okay, so this is the data. Okay, so you've done some transformation to it. Now let me take this. You've done some transformations. Okay, transformations to it. Okay, transformation to it. This is the original data, right? You made this four lines of data into five lines. Let's say you made one more, added one more line. Somehow you've done some transformations. It's up to you what are the transformation you're going to do. I've extracted more data from here. Okay, somehow you done some transactions here, some transformation here. Okay. Okay, so here what happens is transformation. So here what happens, you done some transformation, and this is what created, right? Now let's say this is RDD1, RDD1, okay, and this will be RDD2. Okay, so this is what the transformation looks like. Each transformation will create an RDD2, I mean new RDD. Okay, now let's see here what it says. Once an RDD is created, it cannot be changed. RDD2 is created here, it cannot be changed. This is original. You will still have this original RDD, but this new RDD, right, it cannot be changed. Okay, any transformations applied to RDD creates a new RDD. We just saw that. Any transformations, so we just saw that, right? The transformation applied on this RDD is creating a new RDD. Okay, now leaving the original one untouched, right? Now you created an RDD2 here. You created, done some transformation on top of RDD1. You are able to create an RDD2. Fine. Immutable. Immutable means you cannot change it. So once that is created, once RDD is created, you cannot change it. It cannot be changed. Fine. Immutable, you understand. Because you have some RDD, okay? You created a new RDD on top of that, okay? Now this RDD2 cannot be changed. It's immutable. Okay, fine. Now resilience. You already know fault tolerant. RDDs are fault tolerant. You already know that how. Meaning they can recover from node failures. Okay. This resilience is provided through a feature known as lineage. Lineage means you know, right, the step, a record of all the transformation applied to the base data. Um, lineage means lineage means the process, right? Step 1, step 2, step 3, step 4, step 5. 5 steps. Each steps we represent as a stages. Fine, perfectly fine. In one of the step, actually one of the stages, something got failed. You know, right? If Karthik is making a pizza, right, he will first mix the batter, maida and water, and that stage itself, Karthik got failed. Karthik mixed the wrong water or something. It's a somehow that is not coming up well. Okay, you won't throw the entire ingredients, right? You will just take that task and you will just give it that task to some other person who can do that mix well, right? Then once that mix is done, then you can continue your process. Similarly, that let's say if you fail at that step, right? Let's say you have step 1 2 3 4 5, right? You fail at step 4. Instead of calculating again from the step 1 2 3 and 4 5, then 5, you why can't you do it from the step 3 itself? It's better, right? Instead of going from step, instead of like going from step 1 2 3 4 5, if somehow you got failed at step 4, that means why can't you rebuild from the step 3? You can do that, right? Definitely it's doable. So that's what this resilience is talking about. This lenience is about, lenience means the flow of steps, the order of steps, you can call it the art of transformations, right? Records all transformations applied to the base data. Okay, the base data resilience. Okay, fine. Now lazy evolution, you already know. Without an order, why will you prepare pizza, right? Similarly, lazy evolution approach, RDDs follows a lazy evolution approach, meaning transformations on RDDs are not executed immediately. I already told, right? Without an action, transformations won't happen. Until and unless an action is called, no transformations will get applied. Okay, RDDs are not executed immediately, but computed only when an action like count, collect is performed. You'll get to know what are actions in the coming days. Okay, actions are like orders. Like you got an order of 10 pieces, you got an order of 10 cakes. Right? Without, unless you have those orders, right, you won't do any task. Okay? This leads to optimized computation, right? Optimized computations. Unnecessarily, you do not need to do anything, right? You think in real terms, okay? You are making 100 pieces and keeping it ready every day. Sometimes you got order, sometimes you do not get the order, right? When you do not get the order, the entire pieces got waste, right? You lost some good amount of money. You invested your time, you wasted, right? So that's why this spark will follow lazy evolution. Until unless you do not have any order, it won't do any transformations. Until unless you do not have any action, it won't perform any transformation. Okay, just remember these keywords: action, transformation. Okay, partitioning. RDDs are partitioned across nodes in the cluster. Nodes in the cluster, we already know. In the cluster, nodes means we already discussed. Nodes means executors. Executors means, like who are the persons performing that action, right? That executors, allowing for parallel computation on the separate portions of the data, right? Parallel computation. What is parallel computation? I told you, right? That let's go back to that 100 pieces task only. I just gave you the task to you. Each one get the 20 tasks, 20 pizzas to prepare. That was the task given to you. Are you going to prepare that 20 pizzas? Okay, if it's one woven, this entire 100 pizzas needs to go past through that woven and will come back. It's a sequence, right? If you have 5 ovens, what you will do, each one has 20 pieces to make, then each one will utilize this oven, right? You will take the data, you will take that pizza. Once everything is prepared, you'll put that into oven. Okay, like I'm talking about different people. Like you will do it in parallel. Even when Anisha will do the same thing, and this Karthik will do the same thing, and everyone else will do the same thing. Okay, same process they will do. Okay, so while Anisha is putting that pizza in the oven, same the Karthik will do the same thing. It's a parallel, right? They're doing in parallel. They're not waiting for each other, right? But it's just that Karthik just making sure that all its 20 pieces are going in one by one, right? That order. Okay. So that partitioning, your the tasks are partitioned, right? RDDs are partitioned across the executors in the cluster. You can call it as a nodes as well, allowing for parallel computation and separate portions of the data set. Right? On the separate, like the data set is like the 100 pieces is a data set. In that 20 pieces, you need to, let's make it warm. Something you need to heat it. That now you are working on parallelly to hit them, right? Partitioning in memory computation. You already know this thing, right? Spark will do in memory computation. That's what make this Spark more faster than MapReduce. RDDs can be stored in the memory of worker nodes. Okay, right? Memory means RAM, making them readily available for repeated access and thereby speeding up computations, right? That's what this putting this data into RAM will make you, right? RDDs are stored in memory for worker nodes, making them readily available for repeated access and thereby speeding up computations. Perfectly fine. Distributed nature. RDDs can be processed in parallel across a Spark cluster, contributing to the overall speed and scalability. Right? If five persons are doing the task in parallel, let's say each preparation of each pizza will take 1 minute. Okay, if one person is making 100 pieces, then it will take 100 minutes. Okay, if five persons making that pizza, how much time will it take? Can anyone let me know the answer? If one person is making 100 pieces, it will take 100 minutes. What if the task is distributed among five people? How many minutes it will take? I need the answer. Yeah, someone. It's very easy question actually.
Thank you.
How many? Hello?
20 minutes, huh?
20 minutes. Exactly. Right? That's what this parallelism is making us, right? It's making it's making very fast. Right? It is making the task very faster. Okay? Now fine. Speed and scalability. Right? Speed and scalability in this part. You already know. Persistence. Users can manually persist an RDD in memory, allowing it to be reused across parallel operations. Okay, let's say one of the steps you wanted to perform, right? That step three you perform out of step fives. You step three you need to perform again and again. Okay, let's think in this way: step one, step two, step three, step four, again step two. Okay, after step two, I need to repeat that step two again. Step two, again step five, again step two. Okay, if you observe clearly, I got five steps here. I mean, in the 10 steps, the step two is repeated for three times. Then why do I need to do the step every time? Why can't I store it somewhere? Then I can easily access that, right? Okay, why can't I do that access, right? Um, okay, I'll do one thing. In your home, right, you will make some snacks, right? And you're making the snacks, you need to go through some process. Fine. Now you will do the entire process at once and store it somewhere. You store it somewhere so that whenever you need, you can go and access it. Right? Let's say you wanted to prepare chapati. What you will do? What I will do is, as I'm staying in PG, right? What I will do? I will prepare all my 10 chapatis that needed for my next 5 days. I will put it in store in fridge. Whenever I need chapati, I will take that and I will heat it in a low flame, and then I will eat it. Right? I'm storing it somewhere, some storage, right? Some storage you will need, so that whenever you need, you can access that. That's what this persistence means. Users can manually persist on an RDD into memory, allowing it to reused across parallel operations. Whenever I need in an operation, I can use it. This is use of iterative algorithms and fast interactive use. Fine. Now operations. Two types of operations can be performed on RTDs. One is transformations and actions. So transformation you already know. Whenever any transformation happen on an RTD, it will create a new RTD. Okay. And action. When return a value to the driver program or write data to the external storage system. So right, if you calculate the final value of the data, you need to return it to the driver program or write the data into external storage system. External storage means you take the data from HDFS, put it in S3. By the way, S3 is a storage system in AWS. Okay, right? You need to put that. Then how you will do? Like that is an action, right? This is the transformations. You create how you create that, right? That's process involved there. That transformation, right? Okay, perfect. Still now, anyone has any doubts? No doubts, right? At least, fine. I know these are theory classes, bit boring to you. That's okay, fine. But you need to go through this. Then only you can move into um, these practical classes. Okay, so these actions and all, right? Read, write operations, lazy evolution, linear graph. In this small example only, I'm trying to cover all the parts. Okay, stage you will see what are the steps involved in the plan, job, task, and everyone. Task is the smallest action, uh, smallest action we can call it as, that you can perform on a data. Okay, so web UI, there are many things. If you go through this document once, right, before coming to this class, you will get some fair idea on this thing. Maybe you don't understand. Definitely, if you understand, then you are in somewhere, right? You're in parallel universe. You won't understand this, but just go through this thing. Then you will get to know the terminology. Okay, once you are aware of the technology, then whenever I mention the technology, right, it will be very easy for you. Okay, now let's go to the class again. Till here already we are clear. This spark is very important. That's why we are going in very slow pace. Okay, RDD I could have done completed in just 5 minutes. Okay, RDD means resilient data, distributed data set. That's it. I will tell you some example. That's it, and then I will just read these things, and that's it. Done. But it's in real time, right? You won't get much details about this. You need to remember the examples. Now, in the first stage, you cannot remember the technical terms. Just try to remember the examples. Okay. Then once the examples you remember, then it's easy for you to perform, right? To perform in interviews and all. But interviews, instead of saying the technical terms, if you go on with some example, right, and then interviewer will be very impressed. Okay, that doesn't mean that you all go with examples only. You need to know the technical knowledge as well. But if you could provide some good example, then he will be really happy to hire you. Okay, fine. What is Spark data partitioning? What is partitioning in HFS? You know that, right? What is partitioning? What is splitting? What is that in HDFS? Anyone? Hello? Anyone? What is distribution? What is input splitting in HDFS? Hope you guys are not preparing. Seems like
So it's like dividing of the large data set.
large data sets into smaller data sets.
Smaller.
Yes. So um, that's what distribution is about. Okay. So what is partitioning? Just tell me what you understand by the word partitioning. Just your normal term. I do not want to spark technology because you're not even aware of that partition. Right? Maybe this is the first time. You know partition sometimes, right? Um, you know house
Will divide the way that
divide.
is particular.
Exactly,
Yes.
divide, right? Now,
Yes.
what happens with Apache Spark is the moment it read data from HDFS or S3. By the way, you know, right? HDFS. What is HDFS? S3 is as AWS data storage tool. Okay. The moment it read the data from from HDFS, let's say the moment I ask data from S3, it will give me the entire 1 GB file. It won't give you the I will give you the part 1, part 2, part 3. No, it will just give you the entire 1 GB file. Similarly, this HDFS as well. Even though HDFS stores this 1 GB file as blocks in it, okay, it will never give you that blocks to you. Okay, it's just for its internal working. Whenever someone comes and asks you, just give me my file, it will give you that 1 GB file. That's it. That 1 GB file. Now Apache Spark needs to do that logical chunks during the during the reading from sources. Okay, Apache Spark partitions data into logical chunks during reading from sources like HDFS S3. Okay, so who will do the partitions? Apache Spark. When it will do the partitions while reading the data. Okay, Apache Spark will read the data from sources, and then it will do the partitioning. Fine. Now, the partitions are distributed across the Spark cluster nodes, allowing for parallel processing. Right? I distributed the task. Right? Now I done the partitioning on my data. 1 GB data, I partition. Let's say 5 partitions, 6 partitions, 10 partitions, whatever maybe. I will do the partitioning. Now I got 10 small data, right? Small set of data. Now I need to distribute that. Right? I need to distribute that data, right? You will do some chocolate distribution or something, right? So you need to distribute that data across the Spark cluster nodes, allowing the parallel processing. So who will do? So um, you got the ingredients from the market. Okay, you need to do partitioning, 5 partitions, because you are 5 people, 5 executors, right? In my case, I will call you as executor. Okay, you 5 people are executors to me. You are working for a task to prepare a pizza, right? Now I will take that ingredient from the market. In the from the market only, you won't bring that um, um, that entire, right? You will bring just 5 kg amount content, 5 kg maida. That's it. Now after coming here, you will divide that into 1 kg, 1 kg, 1 kg. You partition that. Fine. Now this 1 kg you will give it to 1%, 1 kg you will give it to 1%. Like that, you are just assigning, distributing the data, right? So that they can start working with that maida, Think in that way, simple example, right? Similarly, this data distribution is the partitions are distributed across the Spark cluster nodes, okay, allowing for parallel processing. Okay? Parallel processing. Parallelly, you people can start working on it. Custom partitioning. Spark by default will do some partitioning, okay, but you can also do custom partitioning. Custom partitioning means users can control data partitioning using Spark's repartition, coalescing, and partition by methods, optimizing data locality for or skewness. Um, this bit complex to you, repartitioning, coalesce, and partition by new terminologies to you, but that's okay. Just remember that you can do custom partitioning as well. Custom partitioning in the sense, if if one of you is very good, very fast, so that you can complete your task in within 1 second, then I can give you some good amount of data to you compared to the other people, right? Right, I can do that custom partitioning as well. Instead of doing this, instead of using every one of you 5 people, I will utilize only 3 people or 2 people. 2 people only. Out of 5, I will use only 2 people. Then I will do 2.5 kgs, 2.5 kgs. Custom partitioning. I will decide my partition size. Based on that, I will utilize the resources I have. The rest 3, I will keep it as is, so that if one more new task came, I will use it there. I will use U3 there. That's something. So you can do that customer partitioning as well. How you are going to do is like via this repartitioning, coalesce, okay, and partition by methods. Fine, perfect. Now, when Apache Spark reads data from a file or HDFS or S3, the number of partitions is determined by the size of the data and the default block size of the file system. If you read this sentence again, you will get to know something. You will remember. You can recall this HDFS system, right? HDFS system, 1 GB of file is divided by 128 MB of size, right? That means you will create 8 blocks, right? Similarly, the default block size of file system will let you decide the number of partitions. If the default size of the block is 128 MB, this 1 GB of file will go and divided into 8 partitions, right? Each one corresponding to a block. That's what it says here. In general, each partition corresponds to a block in HDFS or an object in S3. Okay. For example, if HDFS is configured with a block size of 128 MB, you have a 1 GB file. It would divide into 8 blocks in HDFS. Therefore, when Spark reads the files, it would create 8 partitions and each corresponding to a block. Okay. So this is how this partitioning happens in the Spark side as well. Spark will definitely take that 1 GB file. Then Spark will also do similar partitioning, similar 128 MB of blocks. Fine. That's what this data partitioning is about. Just this is a small example how Spark perform data partitioning. This is the entire data set. Now this is divided into partition 0, partition 1, partition 2. See how this is done. This 3 records here, 3 records here, 3 records here. Now this partition was is given to one person out of 5, right? I will pick only three persons from. Now one person will process that, second person will process this, third person will process this parallelly at the same time. Right? The partitions, this node 1, node 2, node 3. That means um, executors. We call them as executors. Right? This node 1 will do the partitioning. This is for one job. This department ID one job. There could be one more task here for that partition and all, right. So these nodes will start processing your partitions. Okay, this is cluster. These are the nodes, worker nodes. They will start processing your data. That's it. Okay. Yeah, that's pretty much. We will rest the class now. Okay. So transformations, actions, and all, right. We can discuss that tomorrow. Transformations and all. But before coming to tomorrow's class, I will really request you to go through these transformations and action. Okay, not only this document, just go to any website and just see what is transformations and actions in Spark. That's it. Read about that document. Okay, then you can come back and then we can discuss in the class. Okay, that's it for today's class. So any doubts so far?
Me in your WhatsApp group actually, so that I can get the update when the class
Yeah,
starts.
sure. I will add Subhashri. Yeah,
Thank
team,
you.
can someone of you please add Subhashri as well to that WhatsApp group?
I think she's absent today. I think she has
Yeah,
not
she
joined.
mentioned she couldn't attend the class actually.
Okay,
I just added you to that chat, Subhashri.
thank you.
Yeah, yeah. Thank you. Class, any doubts so far? Hope you have
No,
idea about
no
Spark.
doubts.
Okay. What is RDD? You know, right? we saw some good example. What is like how you make pizzas, cakes, right? How the process you follow. Similarly, if you wanted to create some insights out of the data set, insight means information. Okay, so that some information out of this data that was provided to you. Let's say I will give you some transactions done by me for the last 10 days. Okay, you need to go through that and you need to create some output of that information out of that, like how much transaction, what was the highest number of transactions I done in a day. Okay, what was the biggest amount I done in a day, what is the lowest amount I done. Okay, so those kind of things you can get that information out of my 10 days transaction list. Okay, but this 10 days transaction is a data set to me. Now once that is given to you, then you will divide that into multiple tasks, small data. Then you guys will start working on that. Okay, you will assign the task among yourself. You will start working on each portion of the data. You won't work on entire data. Okay, in real time it will never happen. In real time you are going to work on the portion of the data, part of the data. Okay, how this partition will happen based on the size, right? What size in HDFS? Let's say 128 MB. So similarly, you will divide that into 128 MB blocks. That means you will 1 GB file will get divided into 8 blocks. So each block you will start working. You will start analyzing data for that small portion of the data. Everyone will do that. Now once you have that to find some information about that, now you will again combine the data. We already saw that in MapReduce, right? Combine that data and that data will be given to the driver or the some external system. Like driver means we discussed, right? Driver is the main entry point, sorry, heart of this Spark job, right? Driver needs the data, you will put that to driver, then driver will decide like where based on the client request, driver will store the data somewhere, or it will just showcase the data to the client. That's it, right? These are the steps involved. Like, but what are the steps involved? Like step 1, step 2, step 3, step 4, step 5, and each step represents a stage in Spark, right? The task you wanted to perform, right? The entire task, bigger task, that task we are making into small tasks, and we are going to complete that task like simple task. Then once that is completed, we will move to step 2. Okay, step 2 there will be some task. Okay, you will do that. Okay, then step 3 you will have task, then you will do that stage, next stage, right? The step is equal to stage, we call, right? That's how these things happen. But if you again go through this document again, you will get to know most of the things. You will clear definitely most of your doubts once you go through this again. Okay, that's it. Any doubts, you can just let me know. Not only regarding to this class, SQL, Python. Hope you guys started practicing on SQL and Python. If you are not going to start practicing, right, then there is no point of these classes. Okay, SQL and Python are very important. Okay, without them, without having the knowledge on SQL, Python, without practicing, not even just going to YouTube videos, without practicing, you are going nowhere. Okay, just practice. If you have any doubts, any challenges you face while practicing, right, just let me know.
Okay,
Okay.
sir. Yeah.
Oh, have you guys started practicing SQL, Python? If so,
Yes.
what are the websites you are following? What are the source resources you are using? Just let me know. I'll see like what are the websites you are using. How you are practicing. Let's start with Aditi. Like how you are started practice. Have you started practicing SQL and Python?
Yeah. Basically, I started using W3 School
Okay.
and some YouTube videos. And
Okay.
majorly, I'm using that W3 School.
Okay. Okay. You're practicing, right? There you can do some run the query as well. You are doing that, right?
Yes. In the there's an option, write a query and all.
Query and all. Yeah.
Yeah,
Fine.
that is a good
Mm. Okay.
to
Fine. You
practice.
can do that.
Yeah.
Anisha, how you are practicing your SQL and Python?
Seems Python I'm actually using with Jupyter, sir.
Okay.
There and SQL same that W3 school only, sir.
Okay. Fine. It's a good website actually. Yeah, you can just go. But if you have any doubt in that, sometimes they will keep it very short. The W3 schools, right? They will keep the information very short. If you want to know more information, then you can just Google it. Let's say this
Yes,
string,
sir.
data type or type something. You just go and Google it. That's it. You will get more information out of it. Okay. Yeah.
Yes, sir.
Arun, how you are practicing your SQL and Python?
Sir, I'm referring Udemy, sir.
Sorry, you are a
Udemy.
on Udemy. You are picking this
Yeah, Bara.
Bara. Okay.
For Python, Krishna X, sir.
Krish Naik. Fine. Okay. Fine. Like you can go with different resources. Krish Naik, I think he's good. Krish Naik is YouTube channel, right?
No, sir, I have subscription of him in Udemy also.
Okay. I think he has a YouTube channel as well. Yeah. That's also.
He also YouTube channel, also, sir.
Yeah. He's good actually. Yeah, he has some data engineering classes. Some
Yes.
content. Yeah, that's fine. Yeah. Karthik, how you are practicing?
Sir, I will learn how to Anaconda. Sir. Anaconda.
Okay.
Sir, SQL is, I will go through the YouTube. One channel is the Ashwatham.
Hmm. Okay. Okay. Fine, 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 fine.
Python.
So where you are going to start your practicing and all doesn't matter to me, but I'm going to show you two. Let me share my screen. Okay, I'm going to show you two people. Actually, pick from anywhere, but I will tell you from my side who helped me more with my data engineering skill sets. Okay, so there are two channels that especially solve the good problems. Tofik. Okay, so these are the channels. Okay, this Tofik, right? Is this Tofik? Okay. He's the one. Okay, tech uh, TF Tofik. You can search. Okay, so he has some good videos. Okay, you can just go here. There will be some basic playlist. Okay, you can just figure out that. From there you can start practicing. Okay, Tofik or Ankit Bansal. Okay, I'm I use these people for class. Okay, so this he is Ankit Bansal. Okay, so he will help you with all your interview
Hello
preparation.
everyone, welcome
Okay,
back to the channel.
interview preparation and all the, like, they will see. If I go to interview, let's say, take in this way, if I go to an interview, someone asks me some question, I'm unable to solve that question, then what I will do is I will ping this Ankit Bansal, and now Ankit Bansal will solve that problem, and if it's okay, I mean, if that has that caliber, then he will post that into this YouTube channel. That's how these entire videos are. Okay, so he used to take those complex problems that people unable to solve in interviews, then he used to put it into this YouTube channel. Okay, so thanks to these two guys, I've never faced any issues in my interviews. Okay, so whenever I gone to interview, right, I was able to crack this SQL questions because of these two guys. So that's how they posted. They have some 45 examples or something. So if you have gone through that, then that's it. In all the interview, like, there is a pattern, right? All the patterns will get covered in those 45 questions, but that's complex. Okay, start small. Start small. Always start small. Keep it simple, as simple as possible. Every day, just try to do step by step. Okay, then one day you will reach that stage where you can solve any problem easily. Okay, try to follow on LinkedIn as well. LinkedIn, there will be many people who are posting their SQL problems every day, and they even post the solution as well. Just go through that. See, maybe in the first instance you won't understand that. Just try to understand the problem. Then slowly you'll get used to those problems. Okay, SQL a day. Remember this. Okay, every day you need to solve at least one SQL problem, one Python problem at any cost. Okay, it, try to do it in the first thing in the morning. If not possible, before going to sleep, try to do it at least one SQL, one Python problem. If not, you're never going to be a data engineer. Do not miss twice in, right? Do not miss in consecutive days. Maybe you missed it today, then don't miss it in the next day. Okay, try to do one SQL a day, one Python problem a day, definitely. Okay,
Okay, sir. Yeah.
okay, never forgot these things. Okay, that's all. Subhash, do you have anything?
No, no, Ravi.
Sir,
So
can you
thank
repeat
you very much.
the channel name, sir?
Sorry,
Can you repeat the first channel name, sir?
Tofik.
Taufik.
Tofik SQL, you can search.
Okay. Thank you.
Okay, next one I'll get myself. Yeah. Yeah, that's it. Can wind up, right? No other doubts, then we can wind up. Okay.
Thank you, Ravi. Thank you.
Thank you all. Bye.
Thank
Thank you, sir.
Thank you.
Thank you, sir. Thank you.